Hello, I'm Jesse. Let's learn what you need to do to take a picture and put it on a Game Boy. I want to put this picture on my Game Boy. But look at it, it's huge. It has like 24 million pixels. The Game Boy only has 23,000 and 40, which is a lot less. The first thing I'm going to do is crop off the top and bottom to make it the right shape. If the picture were more landscape, then I'd cut off the sides. Now that it's the right shape, we can scale it down to fit on the Game Boy's 160 by 144 pixel screen. Okay, now it's the right size. But look at the colors. Look at all these colors. There's way too many colors. We only get 4 colors, and they're all going to be green. I like green though, it's my favorite color. I hope you like it too. But how do we get rid of all those other colors? One way is to take each pixel's color and find the shade of green that it's closest to. Since we're working with shades of green, we can compare the colors based on luminance, which is how bright they look. Of course, when we do this, there's a problem. It's wrong, or at least it doesn't look great. You can tweak the contrast and brightness of the original image a bit to get it to look a bit better, but you still end up with an effect called banding. We have sharp transitions from one color to the next, where the original picture had smooth transitions between colors. That's because we don't have enough colors to capture the smooth subtlety of the original picture. But we can cheat! We can sprinkle some noise into the original picture so that some of the converted pixels change colors. This gives us the illusion that there are more shades of green than there actually are, especially when you look at it on a Game Boy screen. This noise sprinkling is called dithering, and I'm using the Floyd Steinberg flavor of dithering to do my sprinkling. If all you want to do is get a picture that looks like it's from the Game Boy, then you're done. But if you want to put a picture on a Game Boy, we're going to need to split the picture up into 8x8 tiles, because that's how Game Boy graphics work. A full screen picture turns into 360 tiles, which is a problem, because even though the Game Boy's tile memory can store 384 tiles, it can only access 256 of them at a time. So it'll be okay displaying the first 256 tiles. But if we don't do anything, then the last 104 tiles will be a repeat of the first 104. Luckily, we can use mid-frame address mode swapping to change which of the 256 tiles are being accessed in the middle of the picture. We wait till the Game Boy has rendered this much of the picture, then we quickly change the tile addressing mode so that when it gets to the last 104 tiles, it uses the right ones. Then, when it gets to the end, we have to switch back and start over again. You need to do this switching every time the Game Boy updates the screen, which it does 60 times per second. Maybe you don't want to put your Game Boy through all that address mode switching though. What we can do is try to have fewer tiles. One easy way to do this is to get rid of duplicates. A bunch of these tiles are actually the same. We can just keep one of each. That doesn't get us quite there yet though. So what now? Well, what about tiles that are almost the same? We could group all similar tiles together and use the average tile for that group. That sounds like it might be hard though, and honestly, I'm not really sure of the best way to decide if tiles are similar. The simplest thing I came up with is to treat each tile as a 64-dimensional vector and throw it into the k-means algorithm. Maybe that doesn't sound simple, but let me convince you. A tile is 8x8 pixels big. That gives us 64 pixels. Each pixel is actually a number, 0, 1, 2, or 3. So a tile is a list of 64 numbers. All a 64-dimensional vector is a list of 64 numbers, so the vector part is done. Now that all the tiles are vectors, we have a way of comparing them. We can calculate the distance between two tiles. That way, I don't have to try to think a bunch about what it means for two tiles to be similar or different. I can just get the distance between them and say that's how different they are. You can even take a bunch of tiles and find the average tile. The k-means algorithm is what's going to be putting all the tiles into groups. The most important feature of the k-means algorithm is that I already knew about it. You tell it how many groups you want, and you give it a bunch of vectors, and it'll do the grouping. It's simple because I didn't have to think too much about it. Now we replace the tiles in each group with the group's average tile, and we have fewer tiles. If we made sure to ask for at most 256 groups, then we don't need to do any address mode switching. Now you just need to write some code to copy all the graphics data into the Game Boy's video RAM, and you're done. What's that? This sounds like a lot of work? Well, you're in luck, because I made a website that'll do all of it for you. You just have to pick a picture. You can tweak the contrast and brightness to get it to look better. You can switch between the 360 tile rendering, or limit it to any number of tiles between 1 and 256. When you have it looking how you like, you can download the image in a few different scaling factors. If you're working on a Game Boy game, you can also download just the tiles. Or you can download a ROM and load it onto a flash card to play on your Game Boy. The neatest part is it's all done locally in the browser. Nothing is sent to the server, so I won't be able to look at any of the pictures that you might want to load into this. Even the ROMs are generated locally in your browser using JavaScript. I have 2 ROMs with placeholder data, and the JavaScript fills them in with the image you want. Then it updates the checksum and downloads the ROM. I hope you have a lot of fun with it. Leave a comment if there's any features you might want me to add, or if you'd like me to take a deeper dive into any of the details I skimmed over. If you do make some fun pictures, I'd love to see them. My social media accounts are linked in my channel page, and I'll add them to the video description too. Bye!